Welcome to this video on segmentation and fragmentation, part of our network infrastructure revision series. We will explore how large data is broken down for efficient transmission across network. In this video, we will define the criteria for segmentation and the constraints that lead to fragmentation. We will also differentiate between these concepts and map them to the OSI model to help you prepare for your networking exams. Why do we break data into smaller pieces? Large payloads cannot navigate network media as single blocks due to infrastructure size limits and varying MTU rules. Breaking data down improves reliability and allows for easier fault isolation during transmission. Segmentation occurs at layer 4, the transport layer. It involves breaking large application data into smaller, manageable units called segments, primarily using the Transmission Control Protocol, or TCP, before the data is processed by the network layer. Segmentation works by taking raw application data and using a transport layer engine to divide it into ordered segments. This process enables efficient multiplexing, flow control, and uses sequence numbers to ensure reliable end-to-end delivery. To remember the fundamentals, segmentation is managed by the transport layer protocol stack, like TCP, and happens within the host's operating system. A helpful mnemonic is, TCP performs segmentation at layer 4 to output segments. Fragmentation occurs at layer 3, the network layer. It is the physical action of slicing an existing IP packet into smaller fragments when a network link cannot handle the original packet size, typically using the Internet Protocol. Fragmentation is triggered by maximum transmission unit, or MTU, limits on router interfaces. For example, if a 3,000 byte packet hits a 1,500 byte MTU limit, it must be fragmented. Notably, reassembly is performed by the destination host, not by intermediate routers. When a large IP packet arrives at an interface and exceeds the MTU, the fragmentation engine triggers, splitting the packet into smaller parts. This allows data to successfully traverse diverse networks with varying link constraints without being dropped. Fragmentation happens within router hardware or local routing engines, using IP header fields like identification and flags to track the data. If a fragment is lost, the entire bundle is discarded, causing retransmission delays. Remember, IP performs fragmentation at layer 3. In summary, segmentation uses TCP at layer 4 to create segments for general transport, while fragmentation uses IP at layer 3 as a reactive measure to specific physical link MTU limitations encountered during transmission. The data pipeline starts at the application layer, which produces raw data. The transport layer segments it, and the network layer wraps it into packets. If an MTU limit is reached, the router fragments it, and finally, the destination reassembles the data. This chart maps the process. The application produces data, layer 4 handles segmentation, layer 3 manages fragmentation, layer 2 wraps data into frames, and layer 1 transmits the final bit stream. For your exams, remember these scenarios. A host dividing a large file using TCP is an example of segmentation. A router breaking down a packet to fit a narrow VPN tunnel path is an example of fragmentation. Finally, here are a few review questions. TCP handles segmentation at the transport layer. MTU limitations force fragmentation at the network layer. And remember, the final reassembly of fragments happens only at the destination end host. To help you memorize these concepts for your exam, use this formula. TCP segments data, while IP fragments packets. Follow this PDU pipeline. A raw data stream is segmented at layer 4, travels as packets, and if a limit is hit, is fragmented at layer 3. In summary, segmentation optimizes software delivery at layer 4, while fragmentation acts as a layer 3 patch for physical link constraints. TCP drives segmentation, and IP drives fragmentation. Mastering these mechanics is essential for passing your enterprise routing exams.